Hello and good morning to one and all. This is Rasayan Shikshak and we are on second day for lecture series of class 10. Yesterday we were introduced with the chapter chemical reactions and equations. Today we will see some important activity based questions of NCERT which are also important in the viewpoint of CBSE exams. So first of all, activity 1.1. What is activity 1.1? It is said about burning of magnesium ribbon. There are some important questions, few important questions which are more oftenly asked in CBSE exams related to the activities also. During burning of any substance, what happens? Imagine what happens. The substance combines with oxygen. The particular substance combines with oxygen. Here also the same thing happens. So when we burn the magnesium ribbon, it combines with oxygen, and what happens? Let us inquire with the help of reaction. As you all know, the symbol for magnesium is Mg, and when it combines with oxygen, that is O2, it becomes MgO. Now see, is the reaction balanced? Here there is one atom of magnesium, here then there is one atom of oxygen, but there are two atoms of oxygen here and only there is one atom of oxygen on the product side. So what we will do? We will put a 2 here. What happens now? Here there are two atoms of magnesium but there is only one atom of magnesium here. So we will also put a coefficient as 2 here also. Now the equation is totally balanced. See students, what happens when the magnesium ribbon is burnt? It turns into a white dazzling powder. The flame which is produced is white dazzling in nature, and the powder which is produced is chemically magnesium oxide. What is this? Magnesium oxide. There's an important question related to this activity, that the magnesium ribbon is cleaned before burning. What happens when the magnesium ribbon is kept open to air? Again, concentrate here. When the magnesium ribbon, this is the magnesium ribbon, when it exposed to air, what happens? It combines with oxygen and oxide layer is formed on its surface. So what happens if the oxide layer is formed on the surface of magnesium, and when you will burn it, it will not burn due to this oxide layer. This oxide layer prevents further oxidation of the particular element. So if you want to remove this oxide layer, the magnesium ribbon should be cleaned before burning. So magnesium ribbon should be cleaned before burning to remove oxide layer. Let us review activity 1.1. In activity 1.1, it is said about burning of magnesium ribbon. We came to know that the magnesium ribbon should be cleaned with a sandpaper before burning to remove the oxide layer. Why? Because when it is exposed to atmosphere, an oxide layer is formed which prevents further oxidation of the particular element. Also we have seen that when we burn magnesium ribbon, a white dazzling flame is produced, and the white ash which is produced, it is chemically magnesium oxide. This is the balanced chemical equation for the whole phenomenon. Amongst these 2 or 3 questions, the CBSE may ask any of the questions, so it is also important in the viewpoint for CBSE exams also. Yesterday I said that in the due course of this chapter, you will get to know different types of reaction, and we are seeing the same. In the first activity itself, we have seen that the magnesium ribbon combines with oxygen, or we can say that this is burning of magnesium ribbon to convert into magnesium oxide. Now, in the next part, activity 1.2. See, in activity 1.2, there's a reaction between potassium iodide and lead nitrate. Students, you have already studied about the formula, compound formula, or how to make formula of the compound in class 9th. So, potassium iodide, the formula for potassium iodide is Ki, and the formula for lead nitrate is PbNO3 twice. These are the reactants. Now what happens when potassium iodide reacts with lead nitrate? See, there will be an exchange of the ions between potassium iodide and lead nitrate, and what will form? Here it will form lead iodide plus potassium nitrate. Again, you have to see that whether the reaction is balanced or not. Here the iodine, number of iodine atoms is 2, but here it is only 1. So what you will do? We will put a 2 here. Then the iodine atoms become 2, here also 2. But here the potassium, the number of potassium atoms becomes 2, and here it is only 1. So you have to put a 2 here also. The case for nitrate is okay. Why? Because it is already NO3 twice here. So basically, again concentrate students, the potassium iodide reacts with lead nitrate to form PbI2, that is lead iodide and potassium nitrate. Lead iodide क्या होता है? देखो, lead iodide precipitate हो जाता है. Precipitate कैसे किसे कहते हैं? जब भी हम किसी दो सब्सटेंस का केमिकल रिएक्शन कराएं और ऐसा सॉलिड सब्सटेंस जो कि इनसॉल्युबल हो और वो रिएक्शन मिक्सचर के नीचे जाके डिपॉजिट हो जाए, उसे हम प्रेसिपिटेट कहते हैं. किस कलर का प्रेसिपिटेट होता है? दिस इज येलो प्रेसिपिटेट. द कलर ऑफ दिस प्रेसिपिटेट इज yellow. So the reaction between potassium iodide and lead nitrate gives lead iodide and potassium nitrate. As you see that there is a exchange of ion between these two compounds. This type of reaction is called double displacement reaction. So, the CBSE may ask directly the reaction between potassium iodide and lead nitrate, and it may ask that which type of reaction is this. The color of the precipitate may be asked, so you should remember this since they are important in the viewpoint of your exams. Now we are coming to activity 1.3. What happens here? We are taking aqueous solution of hydrogen chloride, that is hydrochloric acid. Remember students, I want to tell you one important thing, that the hydrogen chloride and hydrochloric acid, these two things are different. Remember, hydrogen chloride is a gas and its aqueous solution is called hydrochloric acid. So what happens if the zinc reacts with hydrochloric acid? Then it leads to formation of zinc chloride and hydrogen. Yesterday we have seen that we can know about whether a chemical reaction has taken place or not by the factor if any gas is evolved, or we can test the gas also. Here the hydrogen gas which is evolved, it burns with pop sound and which confirms the presence of hydrogen. So it may ask that, the question may ask that if a metal or if zinc reacts with an acid, a gas is evolved which burns with pop sound, identify the gas. Again I am repeating how the CBSE asks question. Which type of questions are asked by CBSE? So CBSE may ask that the metal reacting with acid produces a gas which burns with pop sound and identify the gas. So you will write hydrogen if it burns with pop sound. In the due course of the chapter, we will be familiar with several more types of reaction in which other gases are also evolved, and the ways to test those gases are different from those of hydrogen. Now, for today, this much explanation is sufficient. You digest this much. So we will go on a review. Again we will come to activity 1.1. स्टूडेंट्स देखो, अगर हम मैग्नीशियम रिबन को जलाते हैं, ठीक है, तो मैग्नीशियम कंबाइन करता है किससे? ऑक्सीजन से, एक नई सब्सटेंस बन जाती है जिसे हम कहते हैं मैग्नीशियम ऑक्साइड. इट इज सेड दैट मैग्नीशियम रिबन शुड बी क्लीन्ड बिफोर बर्निंग. व्हाई इट इज क्लीन्ड? बी वेरी क्लियर अबाउट इट. इसको लेके आप बिल्कुल क्लियर हो जाओ कि मैग्नीशियम रिबन को हमें क्यों क्लीन करना है. बिकॉज मैग्नीशियम रिबन forms the oxide layer if it is remained exposed to atmosphere. To remove this oxide layer, the magnesium ribbon should be cleaned with a sandpaper. Now, why the oxide layer prevents further oxidation and thus the magnesium ribbon does not burn if you do not clean it? In the next activity 1.2, we have seen that there is a reaction between potassium iodide and lead nitrate, and it leads to formation of lead iodide and potassium nitrate, and I have said that it is a double displacement reaction. Why it is double displacement? We will be knowing more about this reaction. इस reaction के बारे में हम और जानेंगे आगे जब हम types of reaction को take over करेंगे तब. The iodine part, the iodide radical transfers to lead and the nitrate part transfers to potassium. So this is called double displacement reaction. In the activity 1.3, we have seen that when the zinc reacts with hydrochloric acid, it leads to formation of zinc chloride and hydrogen. The hydrogen gas burns with pop sound and thus confirms its presence. So for today, this much. I hope you may like the video, and if you like it, please like, share and subscribe. Thank you.